In this video, I'm going to give you an example of a very important application of an exponential function, and that's called Newton's law of cooling. If you take an object in one environment that may be hotter than the surrounding environment, it's going to cool off proportional to the difference between its temperature and the surrounding temperature. Or if you take something cold, like say take something cold out of the refrigerator, it's going to warm up in proportion with the difference between its temperature and the surrounding temperature. So Newton's law of cooling has a formula that goes like this. The temperature of the object at any particular time is equal to the surrounding temperature plus its initial temperature minus the surrounding temperature. That's the difference between it and the room temperature, times e to the negative kt. Capital T is the temperature of the object. At time little t. T with the little subscript of s is the surrounding temperature, or in other words, the room temperature. Usually it's room temperature, unless you submerge something in water. Then it's the water temperature. T sub 0 or T naught is the initial temperature. And K is a constant that you usually solve for before you go any further. An example of Newton's law of cooling is taking a pie out of the oven. A pie is taken out of the oven. With an internal temperature of 325 degrees. Fahrenheit. It's placed in a 72-degree room on the counter. And after 10 minutes, we took the temperature and it cooled down to 200 degrees. And all these are in Fahrenheit. Hopefully you can see this. What's going to be the temperature after 30 minutes out of the oven? So this is a Newton's law of cooling question because an object was removed. Let me see if I can get this. Removed from a different temperature into a room with a lower temperature. So you use the Newton's law of cooling formula. T is equal to the surrounding temperature plus the initial minus the surrounding times e to the negative kt. The temperature of this pie was 200 degrees. The surrounding temperature is the room temperature. The initial temperature of this pie was 325 degrees minus 72. And it was 200 degrees after 10 minutes after it came out of the oven. So T is 10, so minus 10 K. And so our job is to solve for K, and once we get K, then we can plug it into this formula with T equals 30 and figure out its temperature after 30 minutes. So you can grab your graphing calculator, see if you can solve for K in the same way that I do. So 200 minus 72 divided by 325 minus 72. Take the natural log of that answer and divide it by -10. So there's the K value, 0.068. I'm going to store that into K. And I'll just put algebraic. Oops. And we're solved for K. All right, so if I want to know what the temperature of this pie is after 30 minutes, the temperature of the pie is 72 degrees plus 325 minus 72 times e to the negative. Now after 30 minutes, it's minus 30, and we've solved for K, so I'm just going to put K in there like that, and that's how it goes in my calculator. So 72 plus 325 minus 72 times e to the negative 30K. And so the pie will be at a temperature of about 105 degrees. I'd like you to try one on your own, and we can talk about that tomorrow when you get to class. This is you do. Okay, you're going to take a cold drink out of the refrigerator. Oops. How do you spell refrigerator? I don't know. I call it fridge. With a temperature of 38 degrees Fahrenheit and placed on a picnic table outside with a surrounding temperature of 75 degrees. What a nice day. After 5 minutes, the drink's 45 degrees. What's going to be the temperature of this drink after 20 minutes? We'll see if we get the answer. Talk about that tomorrow.